regression. And on this one, we're told that they're using Spearmans rank. So Spearmans rank in order to work it out. So the first one is that we have to complete the table of ranks. Now they've given us the first one on the second row. So they've given us 1. And we can see that 1 is a 17. And therefore, they're obviously starting with the highest number first and then decreasing. Okay, you can do it either way around, but because this question has already set out which way it wants, then you have to continue doing it the same. So the second biggest value is 14.6, so that's my second rank. And then my third rank is 13.4, but it actually appears twice. So that's my third and fourth rank. So we find the average and we write them both at 3.5. Now I've used my third and fourth. So my next biggest actually goes in as number 5, and then number 6, number 7, and number 8. Okay, so the averaged ones, don't forget you'd miss out the 2 numbers that it would have been. And when we look at the top row, we can see that this would be the first value, the second value, the third is written in 4s, the fourth, the fifth, 6, 7, and then 8. Okay, so I now have my ranked data, which is part A. And then part B asks me to find the correlation coefficient, which is RS. So to do this, I need to go to my calculator, my TI-84, and I'm going to go into statistics and I'm going to edit the list of data. So the first one, I'm just typing in the ranks, is 7, 6, 3, 5, 4, 2, 8, and 1. And then the second category of data is 3.5, 2, 3.5. So again, I'm just typing in my ranks. And once I've got that, I can go to statistics, calculations, and this time it is 2 variables. I have my X data in list 1 and my Y data in list 2, and I'm going to calculate it. And the question asked me to find the R value for the data. Okay, so I now need to go to statistics and linear regression. So again, X data is list 1, Y data is list 2, and calculate. And my R value there is minus 0.671 to 3 significant figures. So that's the first one, and it's 2 marks for the answer, and therefore 1 is for the answer and 1 is for correctly rounding it. And then for part C, you're asked to interpret what that means in relationship to the actual question. So you need to say whether the correlation is positive or negative and whether it is strong or weak. So I would say that that is a negative correlation and it is a moderate correlation. So negative, moderate correlation. And what that means in relation to the actual question is that the faster runners tend to be the younger ones. So the older the runner, the slower they get. And that could be due to being more fit. It could be being more youthful. You don't need to give a reason why, but it's just putting it back into the context. So the older runners tend to be faster than the younger ones. So the older runners tend to be faster. So don't forget with this one that the scale is almost in reverse with the speed because you want to be a lower speed. Okay, so if it's inverse, then the older runners have the lower speed, which is actually better because that's faster. Okay, so maybe their experience makes them a little bit better. And then for part D, you need to suggest a possible reason for why they used Spearmans rather than Pearson's correlation or Pearson's product moment, the PMCC. And there's a few different reasons. One is that perhaps they were not normally distributed. Okay, so if they were not normally distributed, then we tend to use Spearman's rank rather than Pearson's. And the other reason could be that if the data wasn't linear. So if we were to draw the data and it wasn't a linear fit, then we would need to use the Spearman's rank because this works for anything such as a continuous up or down motion, so a exponential or logarithmic data set as well.